So this class is civil engineering or environmental engineering 2601. It's about fundamentals of environmental engineering and science. So since this is the first class, we can spend some time for me to introduce myself and also for me to introduce the whole class. So my name is Yang Wang. Yang is my first name, Wang is my last name. I know it's a very common name you may have heard of. But feel free to call me anything, right? Dr. Wang or Yang. I do want to mention that there's another Dr. Wang in our department, Dr. Jianmin Wang. So he teaches the other 2601 session for the fall semester, actually. And for those who are in the environmental engineering program, you also go through his classes on some senior leveled water treatment classes. So I joined S&T in 2019, so 2 years ago in fall. So I guess for many of you in the, also for the environmental engineering degree, I joined S&T at the same time with you, right? So I'm kind of like a sophomore in the faculty world. But it has been nice to know each other and to working with my colleagues, working with my students. And my research, or other than teaching, I spent almost all my working time on air pollution. So my expertise is on air. So we have quite a few faculties in environmental engineering working on water treatment or biosystems or plant systems. My expertise is in air pollution and specifically on indoor air quality. So because of that, we became quite busy during this COVID pandemic, mainly because based on statistics, 90% of all the transmission are coming from indoor transmission, and it really relates with a lot about indoor environment, right? So we actually are working on some characterization and sampling of air quality, and also specifically on airborne pathogens. And of course, for our campus, we cannot handle experiments with SARS-CoV-2 viruses, although I know that there may be some of the viruses hanging around on the campus. But we're working on some similar pathogens, but much less lethal or benign to human being, so that we can try to get some understanding of how they transmit or how they transport in their indoor environment. And regarding that content, I think we're going to discuss those later this semester. That's going to be the last section, let's say last few weeks of this semester. Since this class is a fundamental class on environmental engineering, so we're going to also cover other environmental problems like water pollution, drinking water treatment, and so on. So that's all about myself. So if you're interested in my research or other projects, you can feel free to talk to me, and actually we can also work with undergrad students on some interesting projects. So now it's about this class, okay? Um, so why do we need to take this class? You may have this question. I know that for my class, there are around maybe 8 students in environmental engineering major that you have to take this class to get your degree. And this is like the first entry class or technical class in your degree, right? And most of you guys are civil engineering students. I would say more of you guys are civil engineering students. And this class is kind of the finalizing class where you're trying to get your degree. You're in your last year at S&T. But that's the requirement for the degree. But in general, why do we put this class in your degree requirement? So we make this a requirement because we want to make sure that everyone knows that there are something in our environment that we shouldn't take for granted. Okay. So for example, if you're thirsty, right, you want a cup of water, you can go to your tap, just get a cup of water. You may boil it or just directly drink it, right? So so where do we get this clean water? It doesn't directly come from river, right? It doesn't come from lake. So when you feel boring, you can go to outside, right? And then enjoy the nice weather, clear sky, right? Clear water. And Also, we have large area of forests, wetland, right? You can provide really nice habitat for a lot of the animals. So these things don't come in natural, right? Don't come in from the natural processes. So people have to maintain these environments because otherwise we may see some very contrast consequences, right? So in a lot of developing countries, people just don't get access. They don't have access to this clean water. And actually, in the United States, we have trouble with these. So I'm not sure if you have heard of the Flint water crisis in 2014, right? So during that time, actually, this is a picture of the residents in Flint, Michigan. Uh, the water they got directly from their tap, right? It contains a lot of organic pollutants and lead. So I think the local government were trying to assure the residents there, saying you can just boil your water and drink it. But actually, later you can find out that if you boil it, then the lead concentration will become much higher, which is more damaging to human health. Okay, so this is not a very distant issue from us. So this picture here is is showing actually a very nice national park in the United States. This is the Yosemite National Park in California. And you see that although most of the time the weather is really nice, right? You have very clear sky, but you're still having some troubles with the air there. There are some periods of time where the air quality in these national parks are affected by human activities because the wind might blow some air pollutants over the forest and cause these hazy weather, right? And if we don't control our solid waste, then we may easily turn these really nice forests into a landfill, right? Although this is not a man-made landfill, but uh, these basically these plastic waste can get accumulated in some natural places and causing some damage to the environment. So that's why in this class we need to know how to control this pollution, right? So we designed, actually people designed water treatment systems and wastewater treatment systems, okay, to manage the water system. So here you may say wastewater is a part of water. So are we talking about the same thing? Actually, no. Okay, so water treatment system in this class, we specifically refer them as the drinking water. Okay, so it's the drinking water treatment system. And the wastewater treatment just means everything that people dump into the environment. It can be from household, it can be from industries, or it can be stormwater, right? Stormwater or snow water can flow by the surface of the ground. And the ground, we know there are a lot of chemicals in there. So we cannot directly drink those water or directly emit those water into the river. So we have to process them before we discharge them into the environment. So in terms of the air pollution, people design a lot of equipments to constrain or to limit the emission of these air pollutants. So for example, here I'm showing a device that's called the electrostatic precipitator. We are going to learn about that later in this semester, but there are a range of air pollution control devices where we can deal with these air pollution systems. So to control the waste or the solid waste, we have the solid waste management systems, for example, the landfill or the recycling stations, right? So we can basically control the emission of these solid waste to better preserve the land systems. So this is why we take this class in general. And of course, we know that during the recent years, people are getting more and more attention onto these environment or the global climate systems. I'm pretty sure that you know this young lady here. Her name is Greta Thunberg. Actually, he was named as the Person of the Year by Times in 2019, right? So the reason why she was under the spotlight was because she is a strong advocate of the global climate change, right? She wants to all of the people mainly, although it's mainly the younger generation, like you guys, but she wants to remind all the adults, right? So the industry, right, in all different like government to realize this severe problem of the air pollution, or not only air pollution, but the global climate change. So, although we have to admit that some of the advocations are kinds of aggressive. For example, uh, I think uh, maybe it's not her, but some of their group was saying that we should ban all the industries and power plants. Okay, we should rely on renewable energy, but that's a very difficult thing to do. So here, what I'm showing is a pie chart of the energy portfolio in the United States. Okay, so this is net electricity generation in 2016. So there might be some changes after 4 years, but I don't expect there are severe changes. So what you can see is that we're still heavily relying on coal. Okay, so you may say that maybe we can get rid of the coal in the next 20 or 30 years. But you see, we're still relying on natural gas, which is another type of fossil fuel. We know that for climate change, the major element or the major factor people want to limit the emission is carbon dioxide. So by switching from coal to natural gas, we're not helping with the problem because finally we're still going to get carbon dioxide. Okay, so only these two species actually occupies 60% or 65% of the entire electricity generation in the United States. So there's no way we can get them or get rid of them overnight, right? If we can do that, then I would say maybe 30% of the people or 60% of people won't have electricity anymore. So that's why while we're trying to reduce the portfolio of these fossil fuels, we also need to come up with pollution control devices to mitigate the effect of these fossil fuel combustion onto our environment, right? You may say we can try to boost up the nuclear energy, but there are a lot of safety issues associated with that, right? So I don't think a normal person will want a nuclear station, nuclear power plant just built, let's say, a mile away from us. Sounds like a threat, right? May turn into a bomb or something. Um, and also for a lot of the natural electricities, for example, solar, wind, or hydroelectric, they're not as stable as those fossil fuel energy, right? Because there are sunny days, there are cloudy days, overcast, right? You have a lot of clouds. Then the electricity amount will just get reduced, right? So um, those are not very stable or reliable sources of energy. So I think for a very long time, we are still going to rely on these fossil fuel energy. It's just that we may come up with better control technologies to mitigate the effect of uh, these processes. And actually, it's nice to see that S&T made a great step, although it may sound like a small step for the entire process. So you probably know that our um, uh, power plant got teared down, I think last year, right? So this is a picture showing the disassembly of the chimney. So it had some quite mixed feeling with this uh, power plant because in my air pollution control class, I always use this as a demo. You can say this is a chimney that's for the emission of the air pollutants, right? You can also go through the all the pollution control devices like the electrostatic precipitator or the cyclones. But now we don't have this anymore. But this is a nice thing. It shows a commitment, right? So the S&T community wants to uh, put an effort for the cleaner or the more renewable energies. So this is why we need to take this class. Okay. So then, what is this class about? So in this class, there are quite many words here. I guarantee that there will be no more these wordy slides in the future classes. But here, so I labeled out some keywords, right? So regarding the contents of this class, so we're trying to mainly understand what are the major cycles of the natural environment. For example, the carbon cycle, nitrogen cycle, and so on. Because once we know these how they cycle within our environment, we know which step is the culprit, right? Which step being is being affected by the human activity, so that we can better control the pollution activities. So also, what is the human impact on these natural cycles? And also, what are the major treatment processes for water, wastewater, air, and air pollution? So we should also add soil pollution, right? So this corresponds with the contents we learned here. We're trying to understand water treatment, wastewater treatment, air pollution control, and waste management, right? So not only we need to know what are the major treatment processes, we need to design these treatment units. Just get a brief understanding of how do they work, right? What are the major dimensions we need to know about for designing these processes? So how to perform experiments that are similar to these treatment processes. You probably realize that when you register the class, you have to register the lab sessions as well. So in those lab sessions, you will learn what are the major methods or the underlying mechanism to control these pollutants, right? And then how to generate lab reports. Of course, for each lab, you need to submit a lab report, give presentations, communicate engineering calculations, and so on. And then also, finally, how to post these engineering solutions. So that's going to be your homework and also the lab report, right? So some general information about this class. We're going to use the principles of environmental engineering and science. This is the third edition. I know that they're starting to sell the fourth edition, but they don't have the hardcover yet. So I think if you want to get a hardcover book, let's use the third edition. And also for the homeworks, it's going to be easier for us to track which one is it, right? So it is okay to use the ebook because for the exams, those are closed book exams. So we're not going to use the books during our exams, all right? And in terms of the grading, there are 4 exams throughout the semester. And each exam, they don't overlap with one another. So basically, when you take the second exam, it's just going to be the contents that you learned during the second section of this semester. So those are not comprehensive. I think it's better we arrange the exams in this way, so you don't need to go all the way back to the first class to track your notes. All right. So for the 4 exams, each of them will account 15 points. All right. So there are 60 points in total. So for the homework, it's 20 points. Lab write-ups, that's 20 points. And then there are in-class quiz. So that will count as the participation. Okay, so that's going to be another 10 points. So for the in-class quiz, I'm not sure if you have done this in other classes. So that's going to be done by the Zoom pooling. Okay, so to just try that out, I have just one pooling question here. Okay, let me just post this. Let's just try it out. It's a simple question here. So I see 27, 28 responded. We're waiting for 3 more people. So I'll give it maybe 10 seconds. Okay, we'll stop here. Let me share the results. All right, so the total score is 110. So basically for this in-class quiz, session, those will be bonus points. Okay, so if you get, let's say if you worked really well with me and with all the contents of this class, and you get a full score, 100, and then you also did well in a quiz, then you'll get 110. Okay, so I think this will boost up the points or the scores for the entire class. But finally, when I count the final scores, the final score will be curved. Okay, so no worries about not performing well in one of the exam or in several of them. All right. So let's continue. And regarding the teaching assistants, so there will be one teaching assistant just covering the lab sessions. So the other one will cover your homework grading. So there will be Mariam and Varuni. So they will also get access to Canvas. If you want to send them a direct message, you can also do that through the Canvas portal. So the office hours will be the same days as the class. It's just 1 hour before the class. Okay. Um, I don't think I will stay there for the entire time. So it would be nice if you can send me an email saying that you want to come during the office hour, and we can decide a time within this 1 hour, right? So I also don't want to keep you waiting for a long time if others are already joining the office hour session. So for the homework assignments, since, as I said in the notification, so for this class, although I chose hybrid teaching modality, for the first half of the semester, we're going to use online synchronous, just like this. We're going to log on Zoom, go through these class notes. For the second half, I'm planning to arrange a few face-to-face sessions. So I'll let you know before that happens, maybe 2 weeks before that happens. Okay, so we all can get prepared. And if you don't want to come to the class, then that's fine as well. You can take it on Zoom because that's still going to be real time. I'll just sit in the class and then go through these slides. So because of that, it's going to be easier if you submit all your assignments by Canvas, right? I think you're now quite familiar with that. It's also easier for the TA to grade it. So the late homeworks will have 20 points deducted. And I think the advantage for Canvas submission is that I can put a hard deadline in there, right? So if you submit it late, it's going to be easier for the TA to track it. So similar to other classes, the assignment should be done on clean paper or by computer. It must be neat, labeled, and organized, right? So the assignment also, you need to give the detailed solution so that it can be fully understood. So we're going to use the appropriate units, the standard units throughout this class, okay? So that will avoid some confusions in there. So you don't need to convert your units back and forth. So feel free to work together, but do not copy or plagiarize because this is the requirement for all the classes, right? Um, so regarding the exams, all the tests are closed book, but you can bring 1 page of your handwritten note. Okay, so that's going to be 1 page there. You can summarize the class notes and also the homework problems, which you think might be helpful for the exam. So no other materials allowed. And regarding the taking the exams, we're going to take it online as well, right? During the through the Zoom session. So post the exam on Canvas, and then you're going to go work through that. And when you submit it, take a picture and then submit it by, through the Canvas. But if it's because of COVID that disrupt your schedule, for example, testing, recovery, or quarantine, please let me know. We can arrange some makeup exams for you, okay? Because this is a special time, and that's why we're taking this online teaching mode, right? So as I said, we also have the lab and the tour sessions. So the lab sessions will be face-to-face. So Mariam is going to meet you guys in room 209 on Wednesday and Thursday. So previously, when when the environmental engineering professors teach the 2601, there are on-site tours. So we're going to bring the students to the Fort Leonard Wood, right? There's a water treatment facility. But also because of the COVID, there are no more visiting programs anymore. So, but we have a lot of very interactive videos. Actually, there are 3D videos. I think maybe they created this because of the COVID. So you can actually even wear your 3D glasses, like a 3D goggle, uh, to uh, to watch those VR videos. Um, so for the lab sessions and tour sessions, there's a lab report due, and that's normally due at the beginning of the next lab class. Okay, you can still submit it by Canvas. So regarding the additional contact person, I'll do my best to solve any problems you might have. But if there are some issues that I can't solve, for example, you really dislike me, I'm a terrible teacher, right? So you can report that to Dr. Joe Birkin. So he's gonna help you resolve the issue. Or if you really like me, because I'm a new faculty here, I can use some nice words from you guys uh, to help me boost up my level among my colleagues. Okay. Um, so that's a brief introduction about the course schedule, and here I'm listing the tentative uh, detailed schedule for which contents we're gonna cover for each class on each day. Um, I'll try my best to follow the schedule here, I think. But here for the exam dates, please keep them in mind because these are solid dates. There are no changes for these exams. Okay, and then here's the exam for, um, unless under very challenging conditions. Okay, and of course, I'll definitely cover all the contents needed for you to attend the exam. And also, if you notice here, we have homeworks due every week, right? So actually, for this first week, we're going to have a short write-up as a homework. And you can use this tentative plan to basically plan your study as well. Okay, so that's all about the general information about this class. So I think we can use the rest of the time to go over the introduction session, introduction chapter of this class to further know a little bit more about the contents of this class and also the history of the environmental protection. So as you can see, the title of the book is Fundamentals of, or the title of the class is Fundamentals of Environmental Engineering and Science. So what is environmental engineering and what is environmental science? Okay, so this is again a page of a lot of words. So I'm trying to summarize the keywords here. So whenever we mention about science, we're talking about some virtual things, right? So something that you cannot directly see, but something you can learn from the book. So actually, environmental science is the systemized knowledge about the natural environment, including the atmosphere, the land, and the water. So it's air pollution, soil pollution, and the water pollution, right? It's going to be drinking water and wastewater. And also their inhabitants. Okay, it's about some animals in there. So, but the major idea is that the environmental science are the knowledge. Okay, so environmental engineering is mainly about the sound engineering thought and practice. Okay, and they're also the solution of problems for the environmental sanitation. So we're providing solutions, we're providing techniques to solve these environmental problems. So these are about the water supplies, for example, the wastewater, right? And also here is about the solid waste. And also the drainage of urban and rural areas, control water, soil, and atmosphere pollution. So it's still about these three different states, right? So we always talk about the states of a matter. It has the solid state, liquid state, and gas state. So we're dealing with the pollution from all states. Solid state is the soil, liquid state is the water and wastewater, gas state is the air, right? So they're also related with public health. So to sum up, engineering is the profession that applies science and mathematics, deals with the design and the application of these ideas, right? So if we wonder what's going to happen if we engineer something without science, okay, so we can easily do that. And actually, people learn lessons from these activities. So here's an example. In 1992, the state of California come up with a new regulation. Okay, so they want to reduce the air pollution. Reduce the air pollution and increase the octane rating. So basically, the higher the octane rating, the better the combustion. So, or the more complete the combustion. Okay, so this is good for the environment because if it's not fully combusted, then we may emit carbon monoxide into the atmosphere. And there are also a lot of volatile organic compounds, VOCs, into the atmosphere. These are air pollutants, right? So the way they reduce these air pollutants is by adding a new chemical that's called the methyl tertiary butyl ether. So this is a pretty awkward name, but let's just name it as MTBE. Okay. So basically, people add a chemical into the gasoline so that you can reduce the emission of air pollutants. Okay. And the US EPA approved that because it's benign to the environment, right? It's good to the air pollution. I mean, it's good to the atmosphere and reduce the air pollution. And later, people realized that there are some chemical properties of these MTBE that is really damaging to the environment. Okay, this is about the environmental science. So people find that MTBE is very soluble chemical. It's a very soluble chemical. It's miscible in water. So basically, there's no way you can separate water or separate MTBE from water. For example, if you want to separate alcohol from water, you can just vaporize it, right? Adding temperature, you can vaporize those alcohol outside. But for MTBE, there's no way you can separate them by heating them up or by filtering it out, right? So it just stays with water. But the thing is that it has a disagreeable odor, and also it's a possible carcinogen. Okay. Furthermore, it's highly recalcitrant, which means that it's very inert. There's no way you can add in some chemicals to change the state of this the MTBE. So what that means is once it's mixed with water, there's no way you can extract it. Okay. So but when people realize this, is a little bit too late. Okay, so uh, as of year 1998, around 30% of all the gasoline used in the United States contain MTBE, and people also found that there are around 2 million underground storage tanks. For example, for the gas stations, they use these underground tanks, right? And then actually 90% of them hold these petroleum products, and 80% of them are bare steel tanks. And these tanks are very easy to leak. And now you can imagine what's going to happen. So we have the MTBE mixed in the gasoline, and then these gasoline are contained in underground tanks. And there's not easy way to detect the leak in these tanks because it's basically buried in the underground, right? So once the MTBE mixed into the soil, they will mix with water. So it's going to affect the drinking water. It's going to affect the lake, river, a lot of the water body, right? It might cause carcinogen if people directly drink those water, right? So this is I would say, a classical example of engineering without science. It's not like we're intentionally trying to dump these chemicals into the water, right? It's not like we're intentionally generating carbon monoxide into the atmosphere to pollute the environment. We're trying to do something nice. We're trying to protect the environment. We added in these chemicals. but that leads to basically more damage to the environment. So that's why to apply our knowledge into engineering, we have to know what is going on with the environmental science. Okay. So now we can use the rest of time to talk about the history of the environmental engineering. So as I said, there are pollution treatment for water, for gas, and for soil. And actually, the water treatment has been a very uh, long history, has a very long history. Okay, because all the civilizations they need water. It's not like air pollution because if the air is very polluted, people can always move to another location. But if there's no water, if the water is polluted, it's going to be difficult for them to find cleaner water. So that's why people have been building up these sewer system for a very long time. So there are historical sites. Actually, people dig out and found that there are sewer systems. For example, in India, Iraq, Italy, all of them are in BC. Okay, so for example, for this one, it's more than 5,000 years ago. All right, and for the one in Italy, that's more than 2600 years ago. But the more amazing thing is that this sewer system is still working. So people in Italy are still using this sewer to as a, let's say, a part of their water treatment system to obtain drinking water. Okay, so you can see that we really have a very long history in treating the quality of the water. And in terms of the modern history, we're specifically talking about the time after the Industrial Revolution, right? So the Chelsea Water Company, the one in London, in the England, so they are the first company that start to practice these water treatment systems. So although it sounds quite silly, so what they did was just use the sand to put a dam, right? Build up a dam, and then just filter the water from the Thames River. So this is a application of the filtration, right? Because of that, you can filter out the bacteria, filter out the larger suspending solids, and so on. And during this modernization of the water treatment, we have to mention two names. So one is John Snow, and the other is William Budd. So they are the pioneers to revolutionize the water treatment system. So what they found is that there's a strong correlation between the water quality and the diarrhea disease. Okay, so what they did was they actually sampled the water quality in the city of London and also counted how many people are suffering from diarrhea. Okay, so you can see there are blocks. You can see a lot of patients, right? And there are also some blocks that don't have many patients. So they sample the water from the system, from their locations, and then counted the bacteria inside. So they found that there's a strong correlation in the contaminated water and the disease. Okay, so that's when people realize that we have to drink clean water to avoid all of these diseases. So more specifically in the United States, people started these practice um, almost at the end of the 19th century. Okay, that started in the state of Massachusetts. So in terms of the modern water treatment plant, for example, if we want to build a brand new water treatment plant, we need to go through the following processes. So they include flocculation and coagulation, softening, sedimentation, filtration, and disinfection. Okay, so for a lot of these terminologies, we're probably quite familiar with them. For example, the filtration, disinfection. I guess many of you use uh, this water filter, Brita, right? So you can filter the tap water further within your home. Basically, you're adding in quite many small particles in this filter media, right? And then let the water to go through to remove the larger suspending solids inside. And for disinfection, we all know that in the swimming pool, they add in chlorine. So chlorine can kill all of these pathogens. So that's why we add disinfection procedure as well, because there are just so many of these pathogens in the environment, right? So we're going to learn more about these terminologies later on. For example, flocculation and coagulation, softening, and sedimentation. So they mean specific procedure to remove certain species of pollutants in the water. And in terms of the wastewater treatment, we're mainly dealing with um, the discharge from industry, from the residents, and also from the stormwater. As I said, the stormwater or the rainwater are not clean because they are going over the surface of, let's say, the road and all the man-made surfaces, right? So there may be a lot of toxins inside. So before we discharge those stormwater into the water, we need to go through this wastewater treatment as well. And also, the one goal for the wastewater treatment is to avoid the contamination of the drinking water. We have to separate them. So if we directly discharge the wastewater or even the processed wastewater into a drinking water facility, then that's going to cause disaster. And also, we want to protect the environment because theoretically, we don't need to do anything to these wastewater, right? It can be totally irresponsible. And then after we pollute one area, we can move to another area, right? But this is trying to show let's say, the responsibility to the environment. And in terms of the history, it also started from UK and the US, and also started later in the 19th century. Solution. It started with the Industrial Revolution, which is around the 18 or 19th or 20th century, right? So here is showing a picture of London, actually. Again, you see a lot of chimneys here and then a lot of black smokes coming out, right? So nowadays, if you go to a power plant, what you see is white smoke. That's because those are processed flue gas. So when black smoke come out, it means that the air there is very contaminated. It contains a lot of unburned carbon, which is a strong carcinogen to human. Okay, so because the Industrial Revolution started in Western Europe, so the air pollution control devices also started from there. Okay, so the first experimental apparatus started in 1824, and people further designed fabric filters, cyclone collectors, and electrostatic precipitators. So actually, it's very interesting to find that nowadays people are still using the same method to deal with the flue gas out of the let's say the industries. Okay, so we're going to talk about how they work and how we design these air pollution control units for the air pollution control. So because there are more stringent requirements or there are more control devices, we can also find some interesting trends in the emission of these air pollutants. So here, what I'm showing is a um, time series regarding the emission of the emission rate of these air pollutants. So I'm showing sulfur oxides. Basically, you can treat it as sulfur dioxide, nitrogen dioxide, volatile organic compounds, particularly matter, carbon monoxide, and lead. Okay, so by looking at these trends here, you see a pretty interesting feature. Okay, so it seems that all of a sudden, near the year of around 1970, all of these emissions dropped down. Okay, so what happened? So this is our second quiz question. So I'm just giving three options here. Okay, 10 more seconds. All right. So I'm going to share the results. All right, so it's actually because of the establishment of the EPA. So the EPA stands for Environmental Protection Agency. So President Richard Nixon uh, proposed the establishment of the EPA in 1970, and it began in operation on December or in December 1970. Okay, so you see that this is very effective. So almost at the same year of 1970, we see this turning point, right? So you may say, uh, well, this is a very strong regulation. So aren't it going to harm the economy, right? It's going to do something bad to the economy to protect the environment, right? Actually, it's the opposite. So here, what I'm showing is the um, growth of the GDP in the United States, and also the emission, or basically the concentration of all of these air pollutants in the United States, starting from 1980. So in 1980, there's a new regulation called the Clean Air Act. So this is also initiated by the EPA. Okay. So what you can see is that while all of these air pollutant concentration reduced, the economy is still going strong, right? And this is mainly because we're basically creating more jobs, right? And then creating more opportunities. And then this is healthy both for the development of the economy and also for the environment. So we shouldn't treat this as a lag for the jobs or for the economy. It's basically opening more opportunities to people. All right. So actually, EPA also came up with a table to regulate what is clean air, what is dirty air, what is polluted air. So, for example, you have the concentrations of carbon monoxide, nitrogen dioxide, ozone, sulfur dioxide, PM10 and PM2.5, and lead. So you can track what are the concentrations here. If it's below this level here, then it's clean air. If it's above this level, it's polluted air. Okay. So we can go through this air quality index, which is quite interesting in our next class. And let's talk about the homework for maybe we can also go over this, go through this overview. So in this class, we talk about the water resource. Um, this is the overview of the entire course, not this class. Okay, so for the entire course, we're going to talk about the fundamentals of chemical systems. We're going to go through some chemical fundamentals of chemistry. I know that some of the civil engineering students, last time you know about the chemistry might be several years ago, but I'm going to awaken you guys from these chemical ideas. Okay, so we're going to talk about the water resources management, spend some time on the drinking water system and wastewater system, also the air pollution and the solid waste. Okay. Um, so for this first week's homework, I'm gonna require you guys to come up with a one-page write-up for some current or some recent environmental problems. Okay, so you can find more information on the Canvas because I posted the entire document. So here I'm just listing a few recent environmental problems. For example, the Flint water crisis. Okay, that's quite recent. So there's also a CNN report on this crisis. This is pretty short. So we have the global warming or the global climate change. This is definitely a hanging problem because finally it's going to happen, right? And then we had the California wildfire last year. This is almost the longest wildfire in the United States history, right? So millions of tons of air pollutants are emitted into the atmosphere, right? We're causing a severe damage to the both the land and the air quality. So, for example, last year people also had the diseases related with the e-cigarettes, and e-cigarettes is also generating particles affecting the uh, ambient air, right? So it also caused some panic because we may have friends who are using the e-cigarettes, and if we walk pass by them, we may inhale some of those particles. It might damage our health too. So there are some other topics on air pollution, but don't restrain yourself onto air pollution. There will be water pollution, soil management, like waste management. So I think, yeah, for civil students, you might be interested in the zero carbon cement as well, because it's not emitting carbon dioxide into the atmosphere. So I also posted some video links here, so you can get some ideas, and also from the YouTube, other related topics. So I strongly recommend you guys to go over this documentary. It's called The Plastic War, talking about how people deal with these recyclable plastics. Okay, so some companies or some industries, they're trying to make the profits as large as they can. So they come up with lies about whether their products can be recycled or not. So this is a pretty long documentary, but this is very knowledgeable. This is very informative. All right. So that's all for this first class. And I look forward to working with you guys for the entire semester. All right. Let me know if you have any questions. So if not, I'll see you next Monday.
Thank you.
Thank you.